Okay, so we are recording. Okay, so the app challenge that I wanted to kind of do today is basically around this kind of fun thing of locating the current International Space Station position and displaying it on a map on your phone. And so we're going to do that in this challenge today. And so the first thing I would ask when you think about an app that's going to do this, if you guys in the chat window could just put in, what do you think are some of the main components or main things that we will need to successfully do that? So again, we're going to want to show in a map where the International Space Station is right now, currently. So what would you think, you know, noodling through the types of things that we're going to need to have access to or use to make that happen? So good, yes. So we'll definitely need a user interface, that's right. What would be some things we're going to need in the user interface? So remember, we're going to locate this position and we're going to display it on a map. So what do we think would be in our interface in the app? Yes, good. A visual representation of where the ISS is. And so we'll do that by putting a marker on a map and show where it is currently. What else do we need? So it's sort of, you know, how do we know where the ISS is, right? I mean, we don't just magically, it's just not going to magically appear. So we have to have some way of getting that information. And so what we need to do is find a cloud service that's giving us that, right? And then processing to convert the location to the visual, yeah, absolutely. So we want to be able to convert this Latin long that we get and make it so that we can show it on a map. So when we go through this, here's what we're going to cover today. And the first thing will be what's referred to as an API. If you have heard of an API before, can you click yes on your participant window? Or type it in the, that's fine. I'm just curious if anybody's heard of yes or API before. Okay, so some have not. Yep. So, okay, good. So this will be new to you, and that's one of the things I want to cover. So the API. The second thing is HTTP requests. How many people think they know what an HTTP request is? We got one yes. So basically, every time you type something in your web browser, it is going to do an HTTP request. So this is how basically we communicate with servers at the other end, is through HTTP. And so we'll cover our basic HTTP requests as a part of this. Now the third one is threading. So we're going to talk about that topic in a little bit, because it's important whenever you're dealing with things over the internet and also dealing with things on your phone. Threading is a big part of making that work right, and so we're going to discuss that. And then another thing is called JSON. JSON we'll go through as far as how we get data back and forth and how it's formatted. And then we'll also look at how we decode that JSON. And this sort of, Joan, goes back to your thing of processing the data that we get so that we can put it on a map and so forth. So those will be the topics we'll kind of go through. So the first thing is cloud services. So when we think about cloud services, you want to think about some service out on the internet, and it stands for Application Programming Interface, and most people don't even worry about the verbiage of that anymore. It's just they all call it API. And an API is what your phone or your computer or whatever it wants, it can use this service to get information. And so you'll notice the arrows on here are going both directions. So they're making requests, and then you're getting data and having data come back. And how do you find these APIs? You basically Google it, is really the best way to do it. So what I did is when I thought, oh, it would be cool to see where the International Space Station is, I Googled for an API that would tell me where the International Space Station is at any point in time. And so this was one of the things that popped up. So there were many different APIs to choose from, but one of the ones I liked about this one is it's free, and as long as you don't request more than once a second, you can use it forever and always get the latest position. So when you have an API, it will typically document two things. One, how do you call it? So if you look at this looks very similar to what you would put in a browser. So you'd say HTTP : and then it's saying api.opennotify.org/issnow.json. That's what you're going to put. That's your URL. That's the HTTP request that you're going to make. And if you do that, here's what you're going to get back. You're going to get back this payload, which is a response. And we have a message, which in this case just says success, a timestamp, which is just the Unix timestamp. And then the ISS position is a lat and a long. So this is a latitude and a longitude on the Earth looking straight up. And that is where the International Space Station should be at that time. So HTTP requests come in a bunch of different forms. The most popular one is GET. So when you do an HTTP GET request, it's a standard request, and all it does is get data. So for example, if I were to go to my Safari here and type in google.com, that was an HTTP GET request, and it gave me back this Google page right here based on that. So this is by far the most prevalent use of HTTP is an HTTP GET. That's what we're going to use when we do the International Space Station. Now, another way to do an HTTP request is with a post. And if you do a post, you actually are creating data on the server. So you could imagine if you're typing in some information like a new book and you wanted to store it in the cloud, you would do potentially an HTTP post request, and that would create a new book out on the internet. Another one is put, which really means that it assumes the data is already there, but you're modifying it. So like, okay, I've got a book title and I want to change the book title. I'm going to do an HTTP put to make that change. And then finally, delete is, okay, I want to delete the book off the server, and I can do an HTTP delete. So when you find an API that you want to use, and again, in your classes, especially with app dev with Swift, if you're going to let them go into using an API, the most prevalent form they're going to use is GET, and they really don't need to know about post, put, and delete. I'm just putting it in there to make it a little more complete. And I will tell you, these are not the only form of these. There are actually 15 different things that you can do, and they all have different meanings. But by far, primarily, these four are the most used, and GET is by far, of that set of four, is the most used. And when you explore an API, you're going to want to use a tool to help you do that. So you're not going to just sit there and type it into your web browser. You want to use a tool. The most popular one right now on the internet by far for all developers is Postman. And it's www.postman.com. And I'll show you why in a second. But this is what you're going to use to explore an API that's out there, to try it out and see, give it a request and see what kind of data that you get back from that. If you can't install Postman on your computer for whatever reason, there is also a website you can just go to, which is apirequest.io, where you can also do very similar things to what Postman does. It's not nearly as complete, but this is something that I wanted to just put in there for those, maybe some kids are on Chromebooks and they can't put Postman on there. They can go to apirequest.io and make their requests. So I want to just flip over to Postman for a second to show you just a quick demo of what it looks like. So don't worry about all this stuff over here on the left. What I really want you to see is right up here at the top where my cursor is. Here's the different, this is where we're going to make an HTTP request. So we have the HTTP request that was the same thing that was documented just previously. This is going to go out to the cloud and request the current location of the International Space Station. And you'll see over here we have a GET, and it's an HTTP GET is exactly what it's going to respond to. But if you look down here, here's all the 15. Here's a post, here's a put, here's a delete, but you can see there's a whole slew of others. I can tell you in my professional career, I've literally only used the 4 that I've told you about. So we're going to do an HTTP GET, and I'm going to hit a send here, and you'll see I now got some information back in this body of a response. And here it matches very similar to what it said it would give us. It said it would give us a message, it said it would give us a timestamp, and then it said it would give us an ISS position, which is another dictionary which includes latitude and longitude. So literally right now, the ISS is at this location in the world. And if I were to hit send again, we would see now this changed from 22 to 23, the timestamp changed. And so every time I hit send on this, I'm going to get back that new position. And so this Postman is a great way to explore APIs and learn about them. So what came back is referred to as JSON. And it's derived off of JavaScript. It's the object notation. So you would think of it as a way to declare objects, very much like in Swift, you declare classes. But basically the world today communicates between your phone and the server using JSON as its way of transferring data. So JSON is one of these things that is easy to learn. It's not complicated, but it is something that people need to understand. We don't send data back and forth in Swift. We don't send it back and forth in Python. It'll always be JSON, or it could be simple HTML. But for the types of stuff we're doing, it's all in JSON. And so if I wanted to show you, this was the payload that we got back, you can see these curly brackets here indicate it's a dictionary. And then you can see here, here's an attribute called ISS position. And then we have another dictionary with the latitude and longitude in it. And then down here, we have an attribute for message and an attribute for timestamp. Now, one of the things that I don't like about this API is you'll notice that they have quotes around the latitude and longitude. And that means that these are not coming through as numbers, they come through as strings. And that's kind of a bummer, because what that means is that when we bring that into our code, we've got to convert that to a number. But that's what we have to live with, because that's the way the API has been built. So if we look at the API here for the JSON, one of the things we're going to want to do in our code is build up something that can hold this. And the way we do that is through structs. And so you'll see here, I have a struct that matches this dictionary right here. So I have ISS position with a latitude and longitude. And then down here, I have another struct which represents this whole thing, which ISS result, which has a timestamp. It has an ISS position, which references this struct up here, and then the message. So this is literally one for one. You'll take whatever you have here and you'll create structs to match the payload that you're going to get. And you'll probably have not seen this before, called decodable. So this is a protocol. This is not inheritance, because structs cannot inherit. But it is saying that it conforms to the decodable protocol. And what that means is that we can automatically have Swift take this and build and populate these structs for us. So we don't have to do that manually. It's all going to be done through JSON decodable magic, which you will see when I get to the code. So how do we decode? So when we have basically this data coming in and we've declared these two structs, the way we actually do the decoding is through this construct right here. And we're not going to go through all of this in a lot of detail. I got to move my chat windows over a little bit here. So what this is saying is we're going to use the JSON decoder, and then it has a decode operation to decode. And then here is the ISS result. This is the structure that it's going to decode, and it's going to come from data. So if I show this, what it means is when we get a response back from the API, we get a response back from the server, it's going to be this string of data. And that's what we're going to supply here. And then based on this, based on the fact that there is a struct already defined here that's decodable, it's going to produce a payload, which we could call this whatever we want, but it is of this decodable, it is of this ISS result struct type, and we now can use it. I could say payload.timestamp or payload.ISS position, and I can just reference it in Swift like I would anything else. And then the try question mark, does anybody have a feel for what they think that does or why that's there? So we're right here. What do they think that might do?
Well, it's an optional.
Yes. So, how do you know that?
Because of the question mark.
Exactly.
So they're thinking it may or may not be resolvable.
It's perfect. Exactly right. So it is possible. So when they wrote this, they know that it's possible that even though you've defined this and that compiles okay, this data that comes in here might not be decodable. This might not match this. And if that's the case, the decode is going to fail. And so if it fails, what do we think payload will have a value of? So if it fails, this try with the question mark is meaning nil, exactly. So this will be nil if it fails. If it's not nil, you know the decode passed properly, okay? Okay, the next thing I want to hit real quick is multitasking. So does anybody have a feel for, want to give me an idea of what we think we mean by multitasking? What does it mean in your life when you're multitasking? So if you're multitasking, what it typically means is you're doing many different things at the same time. So, Joan's, communicating with students on Zoom at 1 minute, and she's eating an apple at the same time, and then she's getting signed up for this thing, and she's multitasking between all of those things. So exactly right, Mary, it's doing several things at once. And that is what iOS does. That is what your operating system does. It does a bunch of things all at the same time, and it does it through multitasking. So one of the things I want to do is relate this to lanes on a street, and the car is going to be the task. That's your task that you're running, and it's the code that you're running on your iOS app. And what I'm showing here is that this car just runs around in a circle as fast as it can so that it can update the display on our phone at 60 hertz or 60 times a second. And so the key to this is that it's in what's called the fast lane or the main thread. And the reason that this car is there and updating the display is if we update too slowly, the user is going to see that. If they try to finger through and slide or move the table view to scroll, or they tap a button and it doesn't respond right away, it's because this guy is not allowed to get around quickly at 60 times a second. So this presents a little bit of a problem. So what happens is if this car here, this task that's been responsible for updating the display, has to go out and request information from the server, this can take time. This is not going to happen instantly. In fact, how many times have you sat and hit something in your Chrome browser or Safari, and you sat and you waited and waited and waited, and then it finally came up? It could be several seconds. Well, if you let this guy that's updating the display also do the request to the cloud, it's gonna look like your app locked up. It's just not gonna be smooth, and it's not gonna work properly. So the way we solve that is we create a second car. We create a second vehicle, a second thread, if you will, that has been assigned a task of going off and getting the data from the server. That could take 2 or 3 seconds. But this car, because we're now, the operating system is multitasking between them, can stay in the fast lane and keep updating the display. And so this is where you get 2 things running at the same time. One of them can go off and do something that takes a long time, and the other one stays on something in the fast lane doing it all the time. So I bring it up because this happens a lot in development. Is students will have very sluggish apps, and the reason is they are using an API, but they're trying to do all the calls to the API on the main thread and not on a background thread, i.e. they're trying to do it in the fast lane, but they need to be over in the slow lane to do it. So when you're in the fast lane, if we call refresh screen, we're green, we're good, and we're moving right along. But then somebody comes along here and says, hey, I need to get data off the internet. And I have yellow here because it's slow. It's not as fast as the other. So what happens is this thing is ahead of this and blocks it, and now it can't refresh the screen because in our lane of traffic, we have this guy that's going really slow and we can't get around them. So the answer to that is to move them over into the slow lane. So, or the right lane, right? We get them moved over, and now over here, nobody's blocking us. This guy can go along and refresh. And so this just kind of shows you one of the ways that this happens. You can use something called a dispatch queue that's a global queue, and async just means that you are asynchronously going to go off and do whatever this is here. This will put whatever is here, this function will run on a background thread. It won't be on the main thread. And then finally, once you get the data and you want to display the data, displaying the data also has to be done on the main thread. So we have to put it back. So this guy right here has to come back on the main thread, and they can do that with this dispatch queue main. So you'll always have the same pattern, and you'll see it when I go through the code of dispatching off to a background thread, go off, get the internet data, and then once you have the data, come back and put it back on the main thread when you want to write back to the display. So the 2 rules are: 1, don't make calls to the internet on the main thread, and I'm going to show you in the debugger how you know if you are doing that. And the second thing is, once you get the data from the server, don't put it onto the display. Like, don't add a annotation to a map, or don't update your table view in a background thread. You want to be on the main thread for that, okay? So making a URL get request in Swift is pretty easy. So what we do is we say let URL. So this is a variable, I just called it URL. URL, all in caps, is a special class. And the string here is the actual string that we're going to call. And then literally all we do is call a singleton, which is a whole nother topic, but it's URL session dot shared dot data task. Again, you will probably just look this up when you need it, but once you have it, you just reuse it again and again and again. This exact same incantation, if you will, is exactly how you'll make requests all the time to cloud services. And you're going to put your URL in here, which is this. And then over here, you'll see in this callback, which is another topic we could discuss, but mainly the code that's right in here in the blank area has access to data, response, and error. These are 3 things that it's going to pass to you when the response comes back. So if you do a GET request and it's successful, response will be code 200, which you don't care about, but that's a successful HTTP response. Error will be nil, and data will have data in it. So it will not be nil. You'll have some data. So let's jump into the code and kind of see what this looks like. So I'm going to go to the app that I've started. And we can go to, here's the main storyboard. So we have a map view in here, and then we have a button that's going to say get ISS location. And the view controller is pretty simple. We have, here's those structs up here at the top. So this is the struct. Remember, it's a struct within a struct. So you have timestamp, the ISS position, which is a struct itself of latitude and longitude, and then message. And you'll notice here I had to declare these as strings because the API gives them to me in strings. So if I want decodable to work, I'm going to need to do that. And then I have an IB outlet for the map view. And how many people here click yes or no if you've used map view before, if you've used the map view function? Okay, Mary, great. Joan, no. Okay. All right. So even, so we again, that could be a whole PD on doing the map view. I'm just going to show you the very basics of what it takes to get it going. And then you can sort of play with it and do all sorts of stuff. So I'm just scratching the surface with this. But essentially what we have is the map view with an outlet here so that we can, I'm sorry, here, so that we can communicate with the map. And then down here in the initializer in ViewDidLoad, we create an initial location, which is basically a CL location coordinate 2D. So whenever you're dealing with, this is core, CL stands for core location. So it's basically, this is the way, excuse me, you would create a 2D location on the Earth. And so you're just saying CL location coordinate 2D. It's like a class constructor or a struct constructor. In this case, I think it's a class. And you're going to give it two parameters, latitude and longitude. So in this case, I put in 418887 and negative 876355. Anybody have a guess as to where that is? You can, don't Google it. Close. That's good. It's actually the Mart where Windy City Lab is, where I used to go to every day that I don't go to anymore. But it's the Merchandise Mart here in Chicago. So what we're doing here is we create this location, and then we have this little extension which creates a region, which we're not going to discuss now, but ultimately creates a region on the map, and then it centers the map to this particular location. And then once we have, and then we also create a annotation point, and I just called it home. And then home.title is home, home.coordinate is this initial location, and then we add the annotation. So in theory, when we run this, we should see a map with the city of Chicago zoomed down to a certain level, which we do. And then here is the annotation with the word home in it. And that's now where we start out. And then what we want to do is when we click this get ISS location, I want this map to change, and I want it to drop one of these annotations where the International Space Station is. So the way we do that is we have a button tied to this function here. So for example, if I just put a breakpoint here, and I come back and I say get ISS location, we hit that breakpoint and we know that we're linked up properly. So this is where we're actually going to make our request to the server to get the location. So the first thing I'm going to do, so you guys don't watch me do a lot of typing, I'm going to just grab some of the code here. So the first thing we want to do is actually create the URL that we're going to communicate with. So if we stop this to get all that out of the way. So basically this is what we saw before in the slides. We're saying a URL is going to be constructed of this URL class of string, and here is the HTTP request itself. and then I've put exclamation point at the end of this because the URL may, the URL returns an optional. And that's because it doesn't know if this string is going to be a valid HTTP string. You could just put ABC in here and it would not be considered valid. And then it would want to return nil. But since I've hard coded this and I know this is valid, I'm going to force unwrap it with this exclamation point. And that means I don't need to keep force unwrapping the URL later. So we've created the URL. And then we're going to create the call to actually go out onto the internet and make the request. Now, it turns out that this request right here, when this happens, will automatically be done on a background thread. When you use this, this is not done on the main thread, it's done on a background thread. And I want to show you how you will know that. So I've got to set a breakpoint here and I'm going to set a breakpoint here. So this code is going to run whatever we put in here once we get the data back. So this is going to make the request, and then the data, once the data comes back, we're going to hit line 29 here, and we should have data in the data variable. But when I run it, and I think it moved my breakpoints. So let's put this here. And now we're going to say get ISS location. Okay, so we broke at line 27, and we're on the main thread. And the reason I know that we're on the main thread is says thread 1 here. And over here on the left, you can see it's under thread 1. So when you set a breakpoint and you stop, look over here and see if you're on the thread that you think you should be on. We haven't made a request to the internet yet. So you definitely should be on the main thread because we just hit a UI button and that's part of the UI and that's all on the main thread. But now if I continue, now we've made a request and we are now up. So it didn't, let's see. So now we're at this breakpoint here. And let's see, are we really at that breakpoint? Yeah, so by the way, this is another thing that can be a little confusing with debuggers is a lot of times they don't like the fact that you're breaking on something and there's nothing there. So it's like blank space and it doesn't break very effectively. So if I were to say let foo equal 2 and let's rerun this. And let's take that out and we'll run it again. Okay, so this, that's interesting. This is not on the background thread. This is still showing to be on the main thread. So this is not putting us on a background thread like I had anticipated, which is interesting. That's all right. We'll continue to go through this, and then later on I will submit my findings as to what I investigated on that. Basically, the idea here is that if we needed to get onto a background thread, is my understanding this would do that for us. It doesn't look like in this case it is. So what we can do is say, and then what we're going to do is just put this inside of it. And now I believe we will be on a background thread. Okay. So all I did is I added this in here right in the beginning. This will force whatever is in here onto a background thread. So now when you make your call to the internet, it's being done on a background thread. And the reason I can prove that is you'll notice it says thread 4 here. It says that I am not on thread 1. If I'm not on thread 1, I'm not on the main thread, and that's good. That's where I want to be. And so that basically kind of proves, at least through the debugger, that you are on a background thread there. So what we're going to do next is actually process this data. So if I go here, the next thing I want to do is I want to basically take the data that's here, and I'm going to do an if let. So I'm checking, because this could come back as nil, and if it's not nil, it has good data, we're putting it in the data variable. And then what we want to do is we want to basically take that data and add it into our payload using the structs that we have. So take this out. If we look at the code, here's the try with the question mark. Here's that JSON decode. Here's the class or the struct that we want it to decode to, which is ISS result. And it's from the data that we set right here. And then we let the ISS location be a CL location coordinate 2D. That's no different than what we did right here. The latitude, but notice what I had to do here. The latitude is not payload ISS position latitude, because that came in as a string. And the core location wants this to be a number. So I have to convert it here to a double. And by converting it, it's taking the string value and converting it into a number. And here I'm taking the same thing, the longitude, and converting it to a number as well. So that will then create the payload. So let's just run this. We'll do get location. And if I were to come down here and look at the payload, so it's, again, what's happened here is I'm breaking on a space, which is not good technique, and it has basically removed this from the context of where we are at the break. So it's not showing me payload, but that's all right. We'll keep going, and then we'll see it when we have a little more code in there. So now what the key thing here is we've got this payload decoded, and now we want to actually put it on the map. And the way we do that is through, first of all, getting back onto the main thread. So the way we get back, so we jump off the fast lane, we get over to the slow lane, we make our request, and now that we've got our data, we need to get back onto the fast lane to actually put it on the screen. And so we can do this by grabbing this, and we're not going to go through this code. You're probably saying, thank goodness. But this basically is just the code to put it on the map, all right? So once we do that, we should be able to get a marker onto our map. So if we run it, and I say get ISS location, boom. So apparently we're just off of Australia. There's Sydney, and there is the ISS right at that position. And we got to that point because we requested something from the API. It came back in this data variable. We decoded the data. We decoded that JSON into the structs that we needed here, and we built structs that matched the JSON directly. So we got that payload. Then in the payload, we were able to reference the ISS position lat and long and create a 2D location. And then we were able to create this coordinate region, which is just a zoom region on the map, and then center ourselves based on that location and set the region so that we're basically one of the things that I did here is if you leave the region as a default, you'll be really zoomed in. And so when it's over the ocean like this, it's just all blue and you can't really tell where you are. So I've set the region to be really wide so that when this happens, you can see kind of where you are at this point. And then we just add the annotation onto the map and the map updates automatically. And again, you're doing this on the main thread. You want to always do your UI in the fast lane. So what's cool about this is by the time I'm sitting here talking, if I do get ISS location again, it now shows the new location. So the space station has traveled that far, travels about 20,000 kilometers an hour. And that's how far the space station has gone since we did this. So the other thing I'll just show you, just because I want to show the being on a main thread or a background thread again, if we do a breakpoint right here, we can run this. And if I say get ISS, so can anybody tell me, are we on the main thread or the background thread here? You have a 50-50 chance. So we're on a background thread. That's right, Anna. Very good. Why are we on a background thread? How do you know, I guess? So see where my cursor is over here? So you know you're on a background thread because you're not in thread 1. Thread 1 up here is the fast lane. That's the UI. That's where you are most of the time. Yep. So now if I come down here and I break inside this dispatch main async that puts me back on the main thread, when I break here, what thread should I be in? So all of these are background threads, and you'll never know which one you're going to get, except for one of them. One of these threads is the main thread. Which one is that? So the main thread or the fast lane is thread 1. So now when I run again, oops, I started over. So we'll hit this, we go to there, and then we continue. Notice we did a break here in 34. We're in this dispatch main async, which puts us back on the main thread. And sure enough, we're in thread 1. That's right. Thread 1 is always the main one, and it's the fast one. So when you're writing your code, if you're not going out to the internet and you're just doing a bunch of UI stuff and storing data, you know, locally and just updating your object model and all of that, you're going to do all of that on the main thread. So every time you hit a breakpoint, you're going to be in here. But as soon as you have to make a request to the API, request to the internet, you do not want to be on the main thread because it will lock up the UI, and it's very obvious for beginners when this happens. So with that, we have developed our little app. And so in review, because we have about 8 minutes left, I'll just ask a few questions. First of all, what thread do you use to update the UI on the phone? The main thread, exactly. And what number does that have in the debugger? Yes, and is that the slow lane or the fast lane? Yes, good, excellent. It's the fast lane, exactly. And it's I call it the fast lane because it updates at 60 hertz. So that means that we're going to see smooth interaction on the display because our eyes can't see anything faster than that. So when you're updating the UI, do you always want to do it on the main thread, or can you do it on another thread? So Anna, you're right. You can do it on another thread. So let me ask you, do you want to do it on another thread? Right. No. No, you don't want to. If you update the UI on a background thread, if you do it on a slow lane, it'll literally, you'll be like, well, wait a minute, I called this function to add an annotation to the map and it won't show up for like 2 or 3 or 4 seconds. And all of a sudden it'll just show up. And it's really kind of, aggravating. It's like, what is going on? Those are usually indications that somebody is updating the UI. It's updating something that the user is going to see, and it's doing it on a background thread. And the way you can get caught in that is, like, if I look at the code here, when I got this payload, I'm on a background thread here. If I forget to go back onto the main thread, if I forget to go back onto thread 1 here, then all of this code will run. I won't get any errors, but it'll lag when I watch it. It'll be sometimes it'll happen right away, and then other times it won't happen, and it becomes very frustrating. So you always want to make sure when you're updating the UI, you're always on the main thread. So is it okay to request data over the internet on the main thread? Exactly. No. Can you? Yes. Is it okay? No, 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 no. Do not do that, because your main thread will lock up while waiting on the internet. And if you've got a slow connection, it's going to just look really laggy and slow and so forth. And so I kind of answered that question, why or why not. So that's basically calling APIs. So, the complexity is that mainly I just wanted you to understand that when you do it, you understand the threading and the fast lane and the slow lane. There are APIs all over the place for you to use. One of the things I want to do is just, are there any questions before we wrap up with the homework assignment? By the way, this topic is not beginner level. You guys, if you're sort of hanging in there and kind of getting it, and once you do the exercise and do the homework, which I encourage you to do, and to send me stuff if you get stuck, this is turning you into a swift ninja. These are excellent things to learn, and it really will take you to the next level. So on the homework assignment, what I want you to do is to implement the ISS Tracker app like I did, but I don't want you to use the map view. But I do want you to display when the ISS will be overhead of your home. So it's one thing to run this and see where the International Space Station is at any point in time. I think it would be cool if you had an app that when you ran it, it told you when the next time the International Space Station is going to be right above you, the date and the time. And so the thing to think about here is, well, how am I going to do that? How will I know that? Well, probably that API that Kevin pointed us to also has a different URL call that will give us that exact information. So basically, you're going to find that if you put Postman on, you're going to go, okay, whatever that other call is, I'm going to put it in here, and I'm going to look at the payload that comes down from it, and then I'm going to build up my struct to actually match that, make it decodable, and then instead of putting something on a map, I'm going to just write out to some labels in the app to say, here's the date and time that the ISS is going to be overhead the next time. And I think that'll be kind of a cool piece of information. And it will give you practice in doing this both on the fast lane and in the slow lane, and keeping your background threads and your main threads all aligned. Okay, well, if that is it, any other questions? Don't forget, if you do these homework assignments and you get them in before we start the next class, you get a $25 Amazon gift card. So that's kind of cool. All right. Thank you, Joan, Anna, Mary. Thank you guys, and hope to see you next in the next 2 weeks. And please feel free to ping me if there's other topics you'd like to hear me go through. Take care.